Git can look complicated when every tutorial starts with a long list of terminal commands. But if you're using VS Code, you can understand the complete workflow visually. In this video, we'll install Git, create our first repository, track and restore changes, use branches, resolve a merge conflict, and publish everything to GitHub without spending the entire tutorial in the terminal. We'll use a real project throughout the video so you can see exactly what happens to your files at every step. And by the end, you'll have one simple workflow you can use to manage your own projects with Git and GitHub. Let's jump right in. First, let's check whether Git is already installed on your computer. I'm going to open VS Code, select Terminal from the top menu, and choose New Terminal. Inside the terminal, I'll run git version. As you can see, it returns git version followed by a version number. This means Git is already installed on my computer, so I don't need to install it again. If you also see a version number, you're ready to continue. However, if the command doesn't work or Git is not recognized, just open your browser and search for download Git. Choose the official website gitscm.com and head to the install section. From there, select your operating system. You can choose Windows, Mac OS, or Linux, depending on which computer you're using. Then, choose the recommended installer for your system, download it, and follow the installation steps. Once the installation is finished, make sure to close and reopen VS Code. Now, open a new terminal and run git version again. Once the version number appears, you'll know Git is installed correctly and VS Code can detect it. Next, let's open the project we'll be using throughout this tutorial. In VS Code, I'm going to select File, choose Open Folder, and open a folder called My First Project. As you can see in the Explorer, this project already contains index.html, style.css, and app.js. If you watched my previous VS Code tutorial, you'll recognize these files because we created this project together in that video. If you haven't watched it yet and want your screen to match mine exactly, I recommend watching that tutorial first. You can find the link to that video in the description. In that video, we created the folder, added these three files, styled the page, and opened it with Live Server. We won't recreate any of that here. This tutorial is focused completely on Git and GitHub. I'm going to open index.html with Live Server so we can quickly see the existing project. And here is the page just as we left it. Right now we have a heading, a paragraph, and a button. Git will help us track every single change we make to these files on our computer. GitHub is the online service we'll use later to store and share our Git repository. So while Git and GitHub work together, they aren't actually the same thing. Git tracks the project history locally on your machine. GitHub, on the other hand, gives us an online place to host that repository. Now, I'm going to return to VS Code and open source control from the activity bar. As you can see, VS Code gives us an option called Initialize Repository. This project is still a normal folder, so Git is not tracking it. Next, let's configure Git and turn this project into our first repository. Before we can create a commit, Git needs a name and an email address for the author. The name is simply whatever you want people to see in the commit history. It doesn't have to be your GitHub username, and you don't need to retrieve it from anywhere specific. You can use your real name or the name you use professionally. The email address is used to identify your commits. If you plan to use GitHub, I recommend using the email address connected to your GitHub account so it can associate those commits with you. If you haven't created a GitHub account yet, I suggest searching for GitHub on Google first. Then click on github.com. It's completely free to use, so if you haven't signed up yet, you can do so right there. You can find your connected email addresses on GitHub by clicking your profile picture, selecting Settings, and then Emails. If you'd prefer to keep your personal email private, GitHub also provides a private no-reply address on this same page. Just go to the email section and scroll down. You'll find it right here in this section. You can use that address for your Git commits instead. If you don't have a GitHub account yet, you can just use your regular email for now and add or verify that address on GitHub later. Now, back in the VS Code terminal, I'm going to run 2 Git configuration commands to check if my name and email are already set up. You just need to type git config global user.name and also git config global user.email. If both commands return the correct information, you don't need to change anything. If either value is missing, use the commands shown on the screen and replace the examples with your own name and email address. The global option applies this information to every Git project on this computer, so we normally only need to configure it once. First, let me clear the terminal. I'll use Control-C to clear the last message, and then clear the terminal to keep things clean. I also want all new repositories to use main as the default branch. Depending on your Git version and configuration, a new repository might instead start with a branch named master. However, we're going to use main throughout this tutorial, so setting it now will ensure your branch name matches mine. Keep in mind that this setting affects new repositories. It won't rename branches inside any repositories you've already created. To get started, I'm going to run the command you see here to set main as our default branch. Now let's return to the source control view and select Initialize repository. If you prefer using the terminal, the command for this same action is git init. You only need to use one of these methods. For the rest of this tutorial, we'll continue using the visual controls in VS Code. As you can see, the button disappears and our files now appear under Changes. This means my first project is now officially a local Git repository. You'll notice a U beside each file, which means they are currently untracked. Git can see index.html, style.css, and app.js, but we haven't saved them to our project history just yet. The source control icon shows the number 3 because we currently have 3 untracked files. If you want to check this same repository state via the terminal, you can use the git status command. This command shows your current branch and lists which files are untracked, modified, or staged. Looking at the bottom of VS Code, we can see that our current branch is main. At this point, nothing has been uploaded to GitHub. Everything is still stored locally on this computer. Next, let's prepare the project so we can create our very first commit. Before we stage anything, I want to show you one important file that should never be committed to a repository. I'm going to create a file named .env in the root of the project and add an obviously fake API key. This is not a real API key, and we will not use it in the project. It simply represents the kind of private values that a real application would need to keep out of Git. As you can see, .env currently appears under Changes because Git can see it. To fix this, I'm going to create a .gitignore file. Inside that file, I'll add .env. This line tells Git to ignore our environment file. As soon as I save .gitignore, the .env file disappears from source control. The file still exists on your computer, but Git will no longer include it in a commit. To see your ignored files in the terminal, you can use the command git status ignored. Keep in mind that .gitignore simply prevents untracked files from being added to your repository. However, it doesn't encrypt them, nor does it remove any secrets that have already been committed. Now we have 4 files ready to go into our first commit. These files are index.html, style.css, app.js, and .gitignore. Before we create the commit, we'll need to stage these files. Staging is essentially the process of choosing exactly what will be included in your next saved checkpoint. To do this, I'm going to click the plus icon next to each file. As you can see, VS Code moves them from changes into staged changes. The terminal equivalent is git add followed by index.html, style.css, app.js, and .gitignore. You can use either the VS Code controls or the terminal command, whichever you prefer. Just remember, you don't need to do both. To show you how it works, I'm going to unstage app.js just once. Notice that the file moves back to changes, but nothing is actually deleted. The terminal command for this is git restore staged app.js. Now let's stage it again. For our commit message, I'll enter create the starting project. Then I'm going to click the commit button. If you're using the terminal, the equivalent is git commit m followed by your message. As you can see, our source control view is now clean. Our first version is now saved locally, and notice that the .env file was not included. I'll expand the source control graph now to see our first commit on the main branch. To see this compact history in the terminal, you can use git log one line. Next, let's make a quick change and review it using Git. Our app.js file exists, but it isn't actually connected to our HTML page yet. Before the closing body tag in index.html, I'm going to add a script tag that connects app.js. I'll also change the paragraph to say I am learning Git in VS Code. In style.css, I'll also add a rule so the pointer changes when you hover over the button. Let's save both of those files. As you can see, the paragraph is updated. VS Code also places an M beside both modified files. Now I'll select index.html under changes to open the diff editor. The committed version appears on the left, our current version is on the right, and the changed lines are clearly highlighted. To view your unstaged changes via the terminal, you can use the command git diff. You can use either the terminal or the built-in diff editor to see these changes. For this tutorial, we'll continue using the visual editor. I'm going to review both files, stage them, and then create a single commit with a message. The commit message will be connect JavaScript and update the page. As you can see in the source control graph, the project now has a clean starting commit followed by a second commit for this website update. Next, let's use Git history to inspect our work and learn how to recover from an unwanted change. In the source control graph, we can see both of our commits sitting on the main branch. Each commit shows the files included in it, and I can open any file to review that specific commit's changes. If you prefer the terminal, the command to inspect a single commit is git show, followed by its commit hash. To view the history of just one file, I'll select index.html and expand the timeline view at the bottom of the Explorer. If you don't see the timeline at the bottom, just click on the three dots at the top of the Explorer and select it. The timeline view shows all the commits that have changed this specific file. The terminal equivalent is git log one line followed by index.html. Now let's make a change that we don't actually want to keep. In style.css, I'm going to change the button background from black to red and save the file. As you can see in the browser, the change is live and source control marks style.css as modified. I'll open the diff to confirm that this is indeed the only change made. To remove this change, I'll right-click style.css under the changes section and select discard changes. Just a heads up, be very careful with this action. Discarding removes uncommitted edits directly from your working file. The terminal command for this is git restore followed by style.css. Keep in mind that this is different from unstaging. Unstaging keeps your edits in the file, but just removes them from the staging area. Discarding, however, restores the file to its last committed version and completely removes the edit. As you can see, the button is back to black and our source control is clean again. Next, let's use a branch to build a new feature without affecting the main branch immediately. A branch gives us a separate line of work that starts from our current commit. Before we switch branches, we need to make sure our source control is clean. I'll also go ahead and close all these open files. This is important because uncommitted changes can sometimes prevent Git from switching branches safely. I'm going to select main in the bottom left corner of VS Code, choose Create New Branch, and name it Feature Button Message. VS Code creates the new branch from main and switches to it automatically. You'll notice the status bar now shows the Feature Button Message branch. If you prefer the terminal, the command to create and switch to a new branch in one step is git switch c feature button message. Now, let's open app.js and add a small button interaction just below the existing console message. This code selects the button and displays a message whenever someone clicks it. I'll save the file, then head over to the browser to click the button. As you can see, the message appears, so our new feature is working. Next, I'm going to review the diff for app.js, stage it, and commit it with the message add button message. In the source control graph, you can see that feature button message is now one commit ahead of main. Now I'll select the branch indicator and switch back to the main branch. The terminal equivalent for this is git switch main. When I test the button again on main, you'll see the message no longer appears. This is because the feature exists on our feature branch, but it hasn't been added to main yet. To merge it, I'm going to open the command palette using Command-Shift-P on Mac or Control-Shift-P on Windows. I'll type git merge and select feature button message. The terminal command for this same action is git merge feature button message. As you can see, the merge finishes successfully without any conflicts. Now, the button message works on main, and the source control graph shows that main now includes the feature commit. Next, let's intentionally create a merge conflict so I can show you how to resolve it inside VS Code. A conflict happens when two branches change the same part of a file in different ways, and Git can't decide which version to keep. Since source control is currently clean, I'm going to create a new branch named update heading using the same branch controls we used earlier. On this branch, I'm going to change the heading in index.html to say Git project. I'll stage the file and commit it with the message. Update heading on feature branch. Now I'll switch back to the main branch. On main, I'm going to change that same heading to say my Git project. I'll commit this version with the message. Update heading on main. Now both branches have changed the same line in different ways. I'm going to use git merge and select update heading. As you can see, Git stops the merge, and source control marks index.html as being in a conflicted state. Now, Git needs us to choose which heading should be the final version. First, I'll open the file and select Resolve in Merge Editor. The incoming panel on the left shows the changes from the update heading branch. On the right, the current panel contains the version from the main branch. At the bottom, you'll see the result panel, which shows the final version that Git will save. Instead of just choosing one version, I'm going to edit the result panel directly to use the heading, My Git Project, in VS Code. Now both ideas are combined into one final heading. Once the conflict count reaches 0, I'll select Complete Merge. VS Code will then stage the resolved file and close the merge editor. To finish the merge, I'll commit the changes with the message, resolve heading merge conflict. As you can see, the final heading appears in the browser, and the source control graph shows the completed merge on main. Next, let's publish this local repository to GitHub directly from VS Code. So far, Git has only been tracking our commits locally on my computer. GitHub provides an online location for this repository called a remote, where I can back it up and access it from any computer. In the source control view, I'm going to select Publish Branch. If you aren't signed in yet, VS Code will open your browser so you can authorize access to GitHub. Otherwise, if your GitHub is already connected, you can just select your account name. If you don't have a GitHub account yet, head over to github.com to create a free account, verify your email, and then return here. I'll keep the repository name as my first project. Next, VS Code will ask whether you want this repository to be public or private. A public repository can be viewed by anyone on the internet. A private repository is only available to you and the specific people you grant access to. For this tutorial, I'll choose Publish to GitHub Public Repository. Just remember, choosing public means your files will be visible to everyone. Since our .env file is ignored, it shouldn't appear in the list of files being published. Always double-check this list before continuing, and never publish sensitive information like passwords or API keys. VS Code will now create the repository on GitHub, connect it to your local repository, and upload all your existing commits. There's no need to create a new initial commit. Now let's head over to GitHub to view our new repository, my first project. As you can see, the project files and commit history are now online, while the .env file is correctly excluded. Finally, let's test the connection directly from VS Code. First, I'm going to make one small change to the paragraph, stage it, and commit it with the message, update project description. Keep in mind that this commit exists locally first. To upload it to GitHub, I'll simply select Sync Changes. Sync Changes works by pulling any new remote commits first and then pushing our local commits. You can see the arrows in the status bar, which show whether commits are waiting to move between the local and remote repositories. After refreshing GitHub, you'll see the new commit appears right here. That confirms the local change was pushed successfully. Now let's test the opposite direction. On GitHub, I'm going to create a file named readme.md, add a simple project title, and commit the change directly on GitHub. This commit now exists online, but it isn't on my computer yet. Back in VS Code, I'll open the More Actions menu and select Pull. Pulling downloads the new commit from GitHub and brings it into your current local branch. As you can see, readme.md now appears in the Explorer, and the source control graph shows the same history both locally and on GitHub. Finally, let's clone this repository into a new folder. Cloning downloads the entire repository, including all its files and Git history. You normally only need to do this once on each computer. First, I'm going to open a new VS Code window. Then inside the source control view, I'll select Clone Repository. I'll choose Clone from GitHub and then select our project that is my first project. Now, I'll choose a different location so the original project isn't overwritten. VS Code will automatically create the repository folder there. Once the cloning finishes, I'll select Open. As you can see, the files and the complete commit history are now available in this new local folder, and it's already connected to GitHub. As you can see, working with GitHub isn't that complicated, especially when you're using VS Code instead of the terminal. All you need to do is initialize your Git repository, review your changes, stage them, commit them, and finally push them to GitHub. And if you already have a GitHub repository, you can simply connect your local project to it and push your changes directly. And that's pretty much it for this GitHub tutorial. I hope you enjoyed it and learned something new. If you want to see more beginner-friendly tutorials like this, make sure to subscribe to the channel because I have plenty more coming soon.